you very much. Good morning. Thank you very much indeed for inviting me to speak to you. It really is a great privilege and an honour. And I have to say a little bit intimidating as well, because I recognise that you guys know an awful lot. I'm very aware of that whole thing of the wisdom of crowds. So as I stand here, there's one of me, and there's hundreds of you. And so as I try to look across the kind of the whole world and talk about the whole world of water, I realise that maybe I'm just going to be scratching the surface, and actually you guys will know more than me. As I was introduced, my name is Mark Enzer, and in my role as Group Practice Manager for Mott MacDonald, it really is a privilege for me to see different aspects of water all around the world. I see the water sector in many different guises. And so this morning, I'd like to give you just an overview of that, and to try to do that in 40 minutes, which I have to say is quite a tall order. So if we are going to do an overview of world water, I think really we need to start out in space. I hope. So from space, when we look down on this achingly beautiful planet, we see an awful lot of water. It's the blue planet. 70% of it is covered in water. And incidentally, H2O, I've learnt, apparently is the second most common molecule in the whole of the universe. That's second after hydrogen. And apparently it is the most abundant solid material in the universe. Who knew that? But back here on Earth, 97.5% of our water is salt water. And of the 2.5% that's left over, about 70% of that is locked up in ice. There's about 30% of it is underground. And so we're left with less than 1% of our water is in lakes and rivers. So we have so much water on this planet, and yet it's in the wrong place, and it's full of salt. And I guess that's where we come in. It's our job to get clean, fresh water to where it's needed, and then to get it back into the environment with no detriment. And so I reckon that the water sector is the most fundamental sector. It's probably the most important to society, and I have to say, I feel that it's the best sector to work in. What we do really matters. It matters to people, it matters to the economy, it matters to the environment. And so the water sector really does underpin all the rest of society. And I'd say that it's more than just a sector, it's essential to life. And it's easy for us working in the water sector to think, oh, it's just my job, it's what I do, I'm an engineer, I'm an environmental scientist, it's what I do. But I think every now and again, we should stop and think, and we should stop and realise that what we do matters, and that we're part of something that really matters. We're part of something that's making a real difference. And so I think, collectively, we should feel good about that. And maybe just every now and again pat ourselves on the back. But unfortunately, not all is well in the world of water. And we'll see that as we briefly consider this overview, because there are unprecedented challenges for global water sector. And we see that that's going to be the case over the coming years and the coming decades. So what I plan to do in this talk is really have two things. Firstly, I'd like to start very, very broad, give a real high-level overview of the key issues and the trends globally. And then what I'd like to do is focus in on some stuff that may be transferable, or at least, I hope, interesting to you guys in New Zealand from other areas of the world where there's developed economies and more mature infrastructure. And so, if we look at the world of water, there are just so many issues. Many of them overlap in all sorts of complex ways, and it's sometimes difficult to know, are these things causes, or are they effects? Are they trends? Are they problems? Are they solutions? So it all gets a little bit of a mess. It all goes round and round, and it's hard to make sense of it all. So as a simplification, what I'd like to do is just present one huge global issue and what I would call 4 megatrends that are specifically relevant to water, and see those as being really influential for all the other things that we see. So the big issue that I would suggest to you, and really I think this probably comes down to the big issue facing mankind in relation to water, is the combination of water security, energy security, and food security. And it's the meeting point of all those things that ends up being the big issue. And this is increasingly being called the nexus, the water, energy, food nexus. And according to the UK's Chief Scientific Advisor, John Beddington, he said that growing populations, increasing demand for energy, food and water will create what he called the perfect storm by 2030. And he ominously added that climate change kind of adds and complicates all of those things. And so with the global population growing at about 80 million per year, by 2030, it's estimated that the world will need 30% more water, 50% more energy, and 50% more food. And to meet this growing need for water, we can really no longer deal with all of these issues separately because they're so interlinked. And so nexus thinking recognizes that a solution for one of these things really must consider the other two as well. And so just as an example, just to illustrate this, if we consider agriculture, globally it uses 70% of the world's fresh water. And that water is also in demand for the energy sector, to cool power stations, but also to run hydroelectric plants. We also, obviously, use water in our everyday lives. Another example is that the world's demand for food is increasing dramatically, but it's not just the food is increasing dramatically, it's the type of food. There's an increasing demand for meat. And so with meat as a particular example, the Fund for Agricultural Development reckons that it takes between 13,000 and 15,000 litres of water to produce just 1 kilogram of corn-fed beef. And so you see these things are totally interconnected. Another example, final example, is that about 3% of the world's energy, the global energy consumption, is related to water. So you see connections all over the place between food, water and energy. And the solution really is for us to integrate our water, energy and food planning. We need to be globally reducing our water dependency, enhancing efficiency across all of these 3 areas. And clearly this is a global issue that affects us all. And I guess in New Zealand, where you're blessed with land and water and loads of food, it may seem like it's a long way away. But like I say, I'm looking at the big picture, looking from high above. And so for humanity, what's facing humanity, this is probably the biggest issue. But the people who end up at the bottom of the heap, the guys who end up at the bottom of the pile and suffer, the ones who get the brunt of this and the worst deal are the urban poor. And as we see, as we'll see later on, this is a relatively new phenomenon, but it's one that I think as humanity we really need to concentrate on and address. So this issue, food, water, energy nexus, is for us all, but it's the urban poor that get it in the neck. So that's the big issue, and now for the mega trends. Now, a megatrend is a global, sustained, kind of macro-level force that impacts sectors, economies, the society in whole. It affects cultures and affects our personal lives. And through that, it affects really the future course of the world. And there are many of these megatrends to choose from. So I could really have chosen many. What I've tried to focus on, though, are the megatrends that are specifically relevant to water. I could, for example, have chosen something about the rising conflict with extremists. Clearly, that seems to be a big trend that's going on just now, but it's not one that's specific to water. So what I've focused on here are really just those that are related to water. And these megatrends are effectively like train tracks that humanity is going down, there's very little that we can do to stop them. We can't just say, hey, I want to get off the train, I want these megatrends to stop. They don't. There's something that's happening. They're kind of just there. But then how we respond within those trends, that really is up to us. So these megatrends end up being very big challenges, but they also end up being really huge drivers for change. And as we'll see later on, as a race, we humans really only get up and do something when there's necessity. Necessity really is the mother of invention. So sometimes getting a kick in the bum with a megatrend is a good thing for us. Now these particular four, they don't look like good news. Really, as we go through them, you'll feel that they're rather like doom and gloom and a bit like the four horsemen of the apocalypse. But I think at least recognizing them means we can do something about them. And once I've gone through these, I will come back and say a couple of positive things, because there's also a couple of positive megatrends, and we'll come back to those later on. So let's look at each of these individually. And climate change to start with. So climate change, it's really happening. The serious scientific community is in complete consensus about this. There is no longer any serious doubt about it. In September 2013, the Intergovernmental Panel on Climate Change, the IPCC, published its fifth assessment report called IPCC AR5. And the findings of IPCC AR5 are frankly scary. So they say that warming of the climate system is unequivocal. They indicate that each of the last 3 decades has been successively warmer than any of the preceding decades. The global surface temperature is likely to increase by at least 1.5 degrees centigrade. The northern hemisphere spring snow cover has continued to decrease. The Arctic sea ice has continued to decrease. Greenland and Antarctic ice sheets have been losing mass, and glaciers have been continuing to shrink. The oceans are warming. It kind of goes on and on. But the fact is that global warming is happening. And if we look at what we can do about it as humanity, and just refer to something that was said again back in 2013 by Ralph Ciccarone, who is the US National Academy president. And he basically said that there are 3 possible responses, 3 basic possible responses that humans can make to climate change. We can go for mitigation, adaptation, or suffering. And basically you fear that humankind have pretty much given up on mitigation. We're not really doing very well on that. We're not reducing carbon emissions very well. So mitigation is an option, but we haven't really chosen it. Adaptation, we're doing that, we're getting on with that, but it's particularly the rich nations that are doing adaptation. And so effectively, what we're left with is suffering. When it comes to suffering, it's going to be those urban poor again that get it in the neck. And a study from the World Bank warns that 1 billion people living in slums are really at the greatest risk of climate change. It talks in quite some detail about what it is about the structures and why it is that it ends up being the urban poor that get it in the neck. But I think we can just take it as read that when it comes to adaptation and suffering, it's the rich that are going to adapt, and it's the poor that are going to do the suffering. And so what this sets up for us is this really strange issue with climate change, that we can both have too much water and too little water all at the same time. And that is a serious issue for us in the water sector. There's also a growing awareness that water scarcity is going to be one of the most significant challenges facing humanity in the coming century. And the thing is that it's not just water scarcity, but it's also lack of access to water. So at the moment, there's about 780 million people who lack access to an improved water source, which is approximately 1 in 9 people. And on top of this, there's a kind of an additional injustice. As you see on this diagram, the water-stressed areas of the world, you see that kind of that band. And I'd ask you to kind of remember that band, because there's a few other graphs coming up, a few other diagrams coming in the future which pick up on that. But the additional injustice is that quite often what happens is that wet, rich nations import goods from poor, dry nations and are effectively importing the goods and exporting water stress. And so if we look at a diagram of what they call virtual water and see the way that water moves around the world, you see an awful lot of water effectively being imported into places like the UK, and water stress being exported to a lot of those places which are red on the map. So there are a few things that I think we as humans will need to face up to when it comes to water stress. And one of them is that we really are going to have to get used to the whole idea of toilet to tap, the whole idea of reuse. So this idea goes way beyond what the Californians like to call showers to flowers. So I think we're going from showers to flowers to toilet to tap. It's just something that is going to be a necessity. There are parts of the world that already do this. We need to collectively get over our squeamishness and get on with that. As we, sorry, just go one back. So there's these limitations to resources. It's not just about limitations to water. There's also limitations to other resources. And so as the world economy picks up, we instantly see that there's limitations on commodities, and particularly the kind of things that we use in the water industry to build our solutions, concrete and steel. But there's also a big limitation on the human resource. There's a lack of skills already to serve the global water needs, and this is something that needs to be addressed. And if we just stay for a moment considering the human resource issue of water, I came across a really interesting statistic which says that if you include the people who fetch water in the global water workforce, so we're including now the people who collect water, then 80% of the world's water sector workforce is female. Now, when I look out across this audience, I don't see 80% female. This is pretty typical of a developed economy workforce, where we're looking at something like 5 to 10% female. And so that means there's an awful lot of women who are collecting water. In Africa, they reckon it's about 90% of water is collected by women and girls. So there's all sorts of resource limitations. It's not just about water stress, also, I think, huge issues in relation to human resource. So now I'll get on to the population concentration. It's not just about population increase. What we also see is this issue about concentration. It's more people in less area, the whole issue of urbanization. It's estimated that there'll be about 700 million people moving into Indian cities by 2050. And if we consider urbanization, in Asia, the urban agglomerations of Dhaka, Karachi, Jakarta, Mumbai, Delhi, Manila, Seoul and Beijing, all of these already are home to more than 20 million people. And then if we consider the Pearl River Delta, Shanghai and Tokyo, these are forecast to exceed 40 million people each within the coming decade. And then if we look outside Asia, Mexico City, Sao Paulo, New York City, Lagos, Cairo, these are fast approaching being home to 20 million people. And it's all in that band that I suggested you remember. So this obviously doesn't add up very well, where we've got that huge urbanization, the huge water stress, they're all kind of connected. And apparently there was a key breakpoint that happened back in 2008, which was that for the first time in the history of humanity, more people lived in towns and cities than in urban areas. And the trend of the growth in urbanization doesn't look like it's going to stop at all. And so we get this strange effect that just over 100 years, from 1950, where it was 70% who are rural, 30 urban, that flips around to be 70-30 the other way round by 2050, which is quite astonishing. But this is not all bad, because concentrations of people lead to more innovations. It leads to more rapid development of ideas. And there's been some really interesting statistical research. A guy called Geoffrey West, who's a real statistics guru, found that there's a kind of a superlinear effect, that as people concentrate in cities, you get an exponential increase in things like innovation. There's also the potential for an exponential increase in diseases and such like, but there is a positive side. And so that means that as you double, for example, an urban population, you more than double the kind of innovation that comes out of it. There's another interesting effect which is related to population, which is the rampant rise of the middle class. So we see population increasing, but the urban population is increasing much more rapidly than the base population. And interestingly, the middle classes are rising even faster than the urban population. And so it's expected that by 2020, there'll be 1 billion people in the middle class in India and China alone. And it's this income group, the middle classes, which I guess is what we are here. It's us who are responsible for the greatest consumption. You know, it's us who use more per capita than anyone else. And so the rising middle class is another major issue related to population. But again, it's not all bad, because as middle class people, we've got pointy elbows. And the pointy-elbowed middle classes get better service. We demand better service, and we get better service. And as that service increases, it does mean that the service improves to all. So the rising middle class is not all bad, but a really big headache when it comes to consumption. And what does that mean for global consumption? And so finally, I come to the investment constraint. The world economy is still not in a happy place, and it doesn't look like it's going to get there for a long time. But investment constraint is not just about the state of the economy, because even if there is money around, it doesn't often get into water. And this kind of leads me on to the sensitive issue of tariff, and the whole issue of cost versus price, and the whole issue of cost and value and price of water. Because I think globally, we completely undervalue water. And as we've looked at before, it's usually the poorest who end up suffering. And I've got a few numbers which will just hopefully illustrate for you how it comes that the poor end up paying more than the rich. But in a rational water economy, it needs to be that the operation costs, the maintenance costs, and the ongoing investment costs are all covered. And ideally, the price of water should reflect the cost of water. So let's just consider a moment the cost of water and the price of water and how much people are willing to pay. So what you're looking at here is apparently the most expensive bottled water in the world. And that, for 750 millilitres, would set you back $60,000. So if we multiply that up, that's $80 million per metre cubed, which is breathtaking, and I think, frankly, obscene. It is a bit of a cheat, because actually an awful lot of the cost of this bottled water is in the bottle, because the bottle itself is made of solid gold. It comes in a leather case. But for some reason, they've chosen to put 5 milligrams of gold dust in the water. Just obscene. So if we come down from that ridiculous high level to something more reasonable and look at the average cost of water. So this is the real cost of water, and it includes ongoing investment costs, like I said. the average cost of water only, globally, is $2.15 per metre cubed. And the average cost of wastewater only is $2.24. So we're talking, in round terms, an average combined cost for water and wastewater, including ongoing investment, of something like $4.40 per metre cubed, which is pretty good. But then when we compare that to what we are willing to pay, I guess we've all gone into a store and bought a bottle of water. What we're paying there is something like $1,000 per metre cubed. So the cost is $4, we pay $1,000, and we're willing somehow to do that. But just remember the $4 for a moment, because if we compare that to what the poor pay, and the numbers I've got are specifically to Africa, but the same kind of thing is reflected globally, and I can remember being in Mumbai quite recently and being told exactly the same story. The cost of water in a Nairobi slum, it's a 2008 figure, is $38 per metre cubed. And the way that works out is that they don't have water in a Nairobi slum. What has to happen is that you go and collect the water. Like I said earlier on, it's usually the women that go and collect the water, but you go and collect the water, and you pay a water seller who's got a tanker full of pretty dirty water that you wouldn't want to drink. And quite often the tariff for that is that you pay the smallest coin for all you can carry. So let's say you can carry 10 litres, it costs you the smallest coin. If you can carry 25 litres, it's the smallest coin. But if you multiply that up, it's equivalent to $38 per metre cubed. Way more than the $4 that we pay. But the thing is, you wouldn't want to drink that water. It's full of bugs. And so when you get back to your slum in Nairobi, if you want to drink it, you've got to boil it. And if you're going to boil it, you've got to pay for boiling it. And so that will cost you an extra $49 per metre cubed for boiling your water. So clearly an awful lot of people don't boil it, and so they get sick. But if you add all of that up, that means that for drinking drinkable water in an African slum, you're talking about $87 per metre cubed. Of course, they never get a whole metre cubed, but in order to give you the comparison, 87 meters cubed compared to $87 per meter cubed compared to $4.40 that we get out of a tap that you can drink straight from the tap. And then you get this whole issue of the tariff and people saying there's a willingness to pay thing. There's this whole thing of a tariff trap, because if the tariff is too low, people aren't willing to pay for improvements, which then means that you don't get the improvements. And so across the world, tariff is a very, very sensitive issue. But for most of the world, the tariff is nowhere near high enough to pay for decent water, to pay for the ongoing improvements. And basically, you have to break into that negative cycle to get to the situation that we are, paying the $4.40 for something that is world class. So, I think I've made my point on that. Move on to another key economic issue, and this is to do with choice. So I found this interesting statistic. This graph, which relates specifically to developing countries, it indicates over 10 years how the access to water has increased. So you can see that the access to water in the house has increased over that time. Not very much, but it's increased. This is also in the face of increasing population, so it's moved in the right direction. You can also see that the water within 1 kilometre has moved up a bit. But it's not really a very good performance, particularly with the Millennium Development Goals specifically trying to address this. But if we compare that to the rise in mobile phones, we see that people are getting mobile phones a lot quicker. And globally, there are more people who have a mobile phone than there are people who have a toilet. So I would say there's something wrong with us. As a race, we've got it wrong, haven't we? There's another interesting little thing I think to point out here, and I don't really want to get too political and too feminist, but I've already told you about the people collecting water, and some people have suggested that the difference, that gap between the water to house and water with 1 kilometre is really that it's the women that are walking that 1 kilometre. So as far as the men are concerned, there is water in the house. It gets there. It's just that the women get it. And because the men don't get it, and it's the men that are going to put the pipes in, they think the water's already in the house, they don't put the pipes in. So that's just one theory. But actually there is a serious point under that, because it is dreadful for women. It reduces their quality of life, it prevents them doing something better, and that's on a personal level. But on an economic level, it's dreadful for the economy. Just think of the opportunity cost of people having to walk. It's about nearly 200 million people making that walk. If that was turned into something more productive, the whole economy would benefit. Okay, so I think I've spent enough time on the doom and the gloom. So let's consider a couple of more positive trends. So what I'd like to offer to you are these two trends which seem to be going in the other direction. The first one about the absolute explosion of information, and the second about how our capability in innovation is also going exponential. So this diagram here is really just intended to give you a sense of scale that will be familiar. So we are all familiar with gigabytes, and we know, for example, how many photos we can get on a gigabyte card. So let's say that gigabyte is equivalent to a height of a short person. An exabyte is 1 billion gigabytes. And so in comparison, that would be like the diameter of the sun. And somebody has worked out that all the words ever spoken by human beings could be stored in text that would be approximately 5 exabytes. So all the words ever spoken by humans forever would be 5 exabytes. So that sounds big. But according to IBM, 2.5 exabytes of data was generated every day in 2012. Now, there is an argument that most of that is videos of kittens, but we are generating a lot of data. A guy called Buckminster Fuller talked about something called the knowledge doubling curve, and he observed that until 1900, human knowledge doubled about every century. By the end of World War II, knowledge was doubling every 25 years. And today, things are not quite as simple because knowledge grows in different ways. So, for example, nanotechnology is apparently doubling every 2 years. Clinical knowledge is doubling every 18 months. But on average, human knowledge today is doubling every 13 months. However, according to IBM again, when they build out the Internet of Things, this will lead to a doubling of knowledge, doubling of human knowledge every 12 hours. And so there's some kind of really crazy exponential curve going on here about the way that human knowledge is increasing. And the thing is, the more knowledge we have, and the more that interacts with other human knowledge, the more it multiplies. And that's really why it's exponential. We also have an exponential growth in innovation. We've all heard of Moore's law. Moore's law, that's the one where it talks about how many transistors you can get on a chip. And so what Moore observed was every 2 years you could double the number of transistors you could get on the same size chip. And that's been going on now for 4 decades. And it shows no sign of stopping. But Moore's law specifically applies to computers. There's something similar to that happening in all sorts of other areas of human innovation. And I've just chosen one. I took some information off Wikipedia and put it on a graph just to illustrate it to you. But this is just an example of power-to-weight ratio. So from the Wright Flyer back in 1903 to today, the power-to-weight ratio of humans flying machines has been doubling every 13 years. And again, it shows no sign of stopping. But one of the points that I'd like to make on this is that at each point along that, people could hardly believe that they could do any better. It's just that it happened. And so, when people were developing the Spitfire and trying to make that go as fast as it could, they couldn't imagine that someday there'd be some kind of Raptor, or whatever that one is. It's actually a Sukhoi. It's a Russian one. But they couldn't imagine that was going to be there. And we now, at the end of that, can't imagine how it's going to carry on. But they're developing these things called scramjets, which are some kind of hypersonic thing, which will enable our flying machines to go at something like Mach 27. So human beings just keep on going. Innovation is just wild. Another illustration, and a different point that I'd like to make, and I could have chosen all sorts of different illustrations to do this, but this point is really about necessity being the mother of invention. When humans are backed into a corner, we can invent stuff, and it's quite amazing how we do it. So this is the Merlin engine that was used to power the Spitfire that I just talked about. And during the war, it was a matter of strategic, and it's a matter of survival for us to be able to improve the Merlin engine. And so just over the period of the war, the power output of the engine was increased by 32%, but the unit cost of the engine was reduced by 82%. So just over 5 years or so, there was this overall 700% increase in the kilowatts per pound, which is astounding. And that same kind of thing is true in all sorts of ways. Incidentally, with this, the production increased as well. So it started off taking 10,000 man-hours to produce one of those things, and it ended up being less than 3,000. But that's all to do with us being backed into a corner, and when we are, we can invent stuff. And so I would argue that while we have those four horsemen that I discussed earlier, the negative megatrends, we've also got these other things going in the other direction. And there is a hope, there is a hope that we inventive creatures backed into a corner will invent our way out of this problem. So I've talked about the four global megatrends, and we've got basically the four going down and the two going up. What does this mean for us globally? Well, I would suggest that it means different things in different places. And so what I'd like to do is introduce to you this infrastructure maturity curve, because I think this helps to make sense of what the megatrends mean for us in different places. The infrastructure maturity curves look something like this. Effectively, it's a curve which is very familiar to anyone who's looked at adoption of technology. It's very similar to any technology adoption curve. At the bottom of it, we've got this emergence phase, which is really all about just getting started. And there are many countries around the world that at the moment don't have the structures or the institutions. They don't have a proper framework of law or established contracts which will enable them even to get started in developing water infrastructure. There isn't the proper presence of a suitable client and supply chain. There isn't the regulation and standards. And so there's an awful lot of work that needs to be done down at the bottom, the kind of emergence area, just to get started, which is why it's a slow beginning. And that kind of stuff happened in the UK a few hundred years ago. But like I say, in some nations it's still being established now. And that needs institutional strengthening, it needs education, it needs enlightenment, it needs people to address corruption. So all of those things are really big issues related to the stuff I've talked about before, but just to get people started. But then as we move on, the paradigm shifts. And so what's relevant to a developing nation is different. It's still the same megatrends apply to them, but it just applies to them in a different way. And this is really where I would want to focus on what might be interesting to New Zealand from other developed economies, because I would suggest that New Zealand is way up the top of that curve. And we'll just explore that in a minute. I do have I forgot, I had this slide just to show you, to show that this is a real thing, and it's not just me drawing an S on a diagram. These are S-curves taken from America, and you can see clearly the shape of that curve for a variety of different things. Something which is also quite interesting looking at this graph, though, is to see how the new infrastructure is growing much faster than the old infrastructure, which kind of relates back to what I was saying before about how the world is speeding up. So, back to this maturity curve and what it means for us, what is potentially transferable. If we look at the top end, the kind of transition from growth into maturity, I think there are very important transitions to be made. And just to try to illustrate a little bit more about what being up at the maturity end of this curve means, in the UK, for example, we have £350 billion worth of constructed water asset. That's already in the ground, £350 billion of pipes and pumps and treatment works. And each year, added to that, is about £1.8 billion worth of assets. And so what it means is that the majority of the network is already there. The name of the game isn't about just building the network anymore. The name of the game is about maintaining that big machine that works. And so there are quite a few things to think about, the shift in thinking to go from basic growth to the maturity. And on the growth part, the name of the game is just about building. It's all about outputs. And so in that part of the graph, the contractors and the supply chain should be rewarded for getting the pipe in the ground, or, for laying the concrete and placing the steel. And that's the right thing to do, because during the growth phase, where many nations are at the moment, you just need to get the infrastructure built, because that's, the population's increasing, all the rest that we've talked about. But it switches at some stage where you've got more infrastructure that's already built than infrastructure that you're actually building. The mindset has to change. And what we're finding, certainly in the UK, and I'm seeing it in other parts of the world as well, is that there's a subtle mindset change that actually ends up being quite a difficult thing to do. So, for example, if you're a contractor and you like to be paid for building stuff, it feels very alien when the most of the asset is already built, and the right answer to a solution isn't to build something at all. The right answer might be to use some kind of information system that joins things together better. It's kind of getting more out of what we've got rather than just building stuff. And up at that top end, a contractor expecting to be rewarded just for building stuff is expecting the wrong thing. So that it's not just a mindset change, it also means a change in the form of contract, a change in the whole approach. And I think one of the key things in this change is seeing the customer at the top of the tree. And we're seeing this very, very strongly in the UK at the moment. We're just about to move into another 5-year asset planning period. All the plans are in place. We're about to get the periodic review later on this year. But a large focus of this coming asset management plan is on the customer, the ultimate customer. So it's no longer a case of the focus is on the assets, building and managing the assets. The focus ends up being on the customer and customer service. So we see infrastructure almost as a service industry to the ultimate customer. And I think that's exactly how it has to be. And that's one of these subtle changes. There's no way back in the emerging phase of infrastructure development that you'd ever get that kind of thinking. But that kind of thinking is absolutely relevant at the top end. And what you see, and what this diagram tries to illustrate, is that what's most important is the infrastructure in use. And the infrastructure in development is effectively the servant of infrastructure in use. And the construction industry and the supply chain really is the servant of that. it becomes all about the operation and maintenance of the assets to serve the ultimate customer. And so what we find at the top end of that curve is that the challenge is really, again, focused on the customer, but it's all about delivering lower bills, better service, and less disruption to the ultimate customer. And it's to do that in the face of the resource-constrained world, in the face of climate change and all those megatrends, because they don't go away. It's just a nuance, but it becomes all about the customer. And this I've just borrowed from Anglian Water, an example of a UK water utility. And this is their list of what they see are highest priorities for AMP6. And so you see there this thing of the whole life asset performance. It ends up being how that throbbing machine of infrastructure works long term. It's not just about lowest cost of CapEx. You see customer at the center there, and you see also this issue of sustainability, where sustainability has moved from just being everyone needs to have a nice policy statement about sustainability because that's what you do. It's moved to being more center stage and being something that companies genuinely believe in because they see that a more sustainable solution is a better solution. And so these end up being key drivers in AMP6 in the UK. And I guess you can potentially see those same kind of changes coming your way. And so what this leads to is some kind of transformation. In order to make that change, not just the mindset change, but also the change in the way things are done, we see that there's a transformation in 3 key areas. And I'll touch on each of these rather briefly. There's a transformation in delivery, the way that things are delivered, transformation information relating very strongly to that upward megatrend I mentioned about the transformation in not just information management, but the whole information revolution. And also transformation in integration, which is all about being more integrated with the supply chain, being more integrated with customers' needs, being more integrated across the delivery process. And I've got a couple of examples to illustrate that. I won't run through every one of these because that would take me too long. But just picking up on some of these issues related to the transformation in delivery, just mention a transformation which is happening around BIM and GIS. This is an information-related transformation. It's very much part of the mega trend. BIM stands for Building Information Modeling. I guess you know GIS. But the I in BIM and the I in GIS is the same. It's information. It's really about information management. And we see a very clever way of integrating these things. This is an example where you take intelligent master maps and intelligent asset data and terrain data from LiDAR or something, automatically join it together in order to automatically produce a 3D view of what's under the ground. So there's no technician has to kind of laboriously draw that up. It just comes automatically out of the data. An example of big data. Then we have here off-site manufacture and DFMA. DFMA stands for Design for Manufacture and Assembly. And what we see here is a very significant increase in off-site manufacture. One of the reasons is because it reduces disruption to the ultimate customer. So something that would have taken 3 or 4 weeks to build, this is a booster pump station, by the way, it takes 1 day to install. It's manufactured in a factory, in factory conditions, it's tested and commissioned in the factory, brought to site on the back of a truck, and then dropped into foundations. And what we found was that the overall time frame of a job like this used to not even bother about the base slab because the rest of the job took longer. But now, with the installation taking a day, suddenly the base slab is the long lead item. And so that brings attention onto the base slab. So now they're moving away from even having base slabs. You just screw in a screw pile and drop one of these things on it. And what it's leading to is quite a revolution in terms of standardization, because not only does this come on the back of the truck, it's also standard. So you could design it once and then deliver it many times. So a major customer, like Anglian Water or Thames Water, would have a product catalogue with these kind of things in it. So you just take it out of the product catalogue, integrate it into your project, and off you go. This is a brief introduction to carbon reduction. What this shows are all the data points for Anglian Water's AMP5 program, because they not only had a CapEx target, but they also had a carbon reduction target. And what they found was that as they reduce carbon, they reduce CapEx even further. As they reduce carbon, they come up with better solutions that end up also being cheaper. And I've got a little example of that. It's just one of many, but this is to do with tankage. And so here you see the conventional approach that a water company in the UK would have taken, in situ reinforced concrete. It's found that that could be beaten from a carbon point of view by the HDPE solution. It needed a challenge to the standards so that HDPE could be used for something like a contact tank rather than its conventional use as a storm tank. But it ends up being a better solution, lower carbon, lower cost, which then makes the concrete guys say, hey, we can do better than this. And so there's a little bit of competition set up. The concrete guys come back with reinforced concrete using cement replacement, and then they reduce carbon and reduce cost. At which point, the HDPE guys say, hey, we can do better. What we've done, we've drawn a carbon density map where all the carbon is. The carbon in the conventional solution for HDPE is in digging the hole and importing the fill. So if we get rid of digging the hole and importing the fill, we save carbon. So they invented this fantastic thing. It looks super elegant and easy. It's a curved bucket. So you dig the hole exactly the right shape, and off you go. So that ended up saving cost, but when you look back at it saved carbon, but when you look back at the cost, it saves even more cost. So driving down the carbon opened up solutions that were more innovative and better. I am running out of time, so I won't go into the alliance too much, just to say that alliancing is growing significantly in the UK. What it's an illustration of is a growing integration, people collaborating across the supply chain to deliver better solutions. And so what we see in terms of the information side is the development, the build-out of the Internet of Things, which might look like the Internet of Infrastructure, smart infrastructure, big data, data being collected. This was just to illustrate that there's an awful lot of databases that most clients have, and there's a lot of spaghetti between the databases and the users. And the answer is not to rip out the databases and put in a big one. The answer is much more to put in middleware. But that middleware is managing the information that I've talked about before. That is part of the information revolution and is a key part of future innovation, which will drive efficiencies in infrastructure in mature economies. I really want to tell you about this because it's so fun, but I'm running out of time. What this is pointing to is using RFID tags to understand what an asset is. It will call down from the cloud information about the asset. You do whatever it is you have to do on the asset, replace the seal or whatever, type it back into your mobile device. It goes back up to the cloud, and the central asset database is updated. It's pretty fun. And then you can also have the augmented reality of overlaying the virtual world on the real world. So that's just around the corner. It's not here yet, but this is the kind of thing that's coming with the information revolution. So the transformation, and I'm very close to concluding, the transformation needs something to happen. And in order to make it happen, we need, I think, three things. The first one is leadership. Leadership that defines a desirable future and can articulate that future so that we can move towards it. It needs innovation because unless we innovate, we'll just get the same answer. You do the same thing, you get the same answer. If we want something different, we must innovate. Innovation is absolutely necessary. But as we've seen, innovation is actually on an upward curve. And one of the things which unlocks it because quite often the innovation happens low down in the supply chain. What unlocks it is appropriate procurement approaches. And with those three things, with the leadership that can drive towards the change, the innovation, which is the engine for change, and procurement, which is the key to unlocking the change, then we can drive transformation. And transformation is really what the world needs, which brings us back to that world view. And I guess what I just leave you with is suggesting that when it comes down to the subject of this whole conference, reform, the subject of transformation, they're really in the same place. We're all working to the same thing, and hopefully that means that our beautiful planet, our world of water, will have a secure future in our hands. Thank you very much.
Well, thank you very much, Mark, for a really fascinating presentation covering a whole range of topical and relevant issues for our industry. We are not going to have time for questions right now, but Mark's in the country for at least a few more days and for the rest of the conference, so I suggest if you want to take any of those topics up with him, that you do so over that time. Now, Mark, given that you're here for a few more days, I hope you get a chance to travel and see a little bit more of our country, and also we'd like to present to you, in recognition of your presentation, this bottle of wine, New Zealand wine. Thanks. There's no gold dust in it. Please thank Mark again for me.